Hi everyone, welcome back to the CCNA training. In the last class, we discussed about port security and DHCP snooping. You can configure this on your network. You can configure this on your network in order to configure a secure network. And I hope I am audible to you guys and you are able to see the screen. Great. Now we are going to discuss about some topics which were left during switching. When we were discussing switching, we missed out on a topic which is VTP. VTP stands for VLAN trunking and we'll understand how this VTP works. So basically, let's understand this using a topology where we have a switch and a PC is connected to that. Then this switch is now connected to switch 2 and let's say this is connected on FA01. Then here we are getting connected on gig 01, similarly gig 01, and now this switch is again getting connected to another switch. Okay, so gig 02, then similarly gig 01, and we have another end device here on this switch number 3. So this is switch 3, this is switch 2, and this is switch 1. Now we have another device here. Now let's assume that the IP address configured on this device is 192.168.10.1. Then on this device it is 192.168.10.2. Now if we say that when I try to ping from PC A to PC B, it will go successful, right? But if the PC A is a part of VLAN 10 and PCB is also a part of VLAN 10, then the question is that if I try pinging from PCA to PCB, will that go successful? What do you think? Let me know in the chat. Would that work in such topology with given specifications? So let's try this on packet tracer and see what else do we need to do in order to make this communication possible. So let me get the packet tracer. Okay, some of you are saying yes and some of you are saying no. Let's try this practically and understand how this works. So let's try using the same topology. Okay, add 3 switches, switch 0, 1 and switch number 2. Then add couple of end devices. One would be connected to switch 0, one with switch number 2. Let's connect them. Okay. Thank you, Hassan, for sharing the link. Here we have successfully created the topology and now we are going to put PC0 and PC1 in VLAN 10 and let's see if communication occurs or not. So first of all, let's configure the IP address on them and try this out. So we'll go to desktop IP 192.168.10.1. Then on PC1 IP will be 192.168.10.2. This is switch 1. 2 and switch 3. Now if we try making communication between PC0 and PC1, it should go successful. But the moment you put in them VLAN number 10, let's see if the communication works after that. So we'll go to the switch interface, CLI of switch, and say enable conf t create a VLAN. Let's take the number 10 VLAN 10 and then name it as CCNA and take an exit, go to interface fa0/1 and make it a member of VLAN 10 using the command switch port access VLAN 10. Exit and change the name to 1. Now we'll make PC1 as well a part of VLAN number 10 after creating a VLAN on switch number 3. Conf t name it as CCNA, then take an exit, go to interface fa0/1. Let me check. fa0/2 is being connected to PC and make it a part of exit. Now if we try making communication, it will go failed. Let's fast forward this. Okay, so it says in progress and failed. Even if I retry, it goes failed because can someone tell me what we are left with? Is there something to do after like putting them into VLAN? Absolutely. So we have not yet created these ports as trunk ports. So we'll go to these interfaces and make them trunk port. So interface fa0/2 switch port mode trunk. Similarly on switch number 2, we will go to interface fa01 and fa02 as well. We have to create fa02 as well. So switch number 2. We'll select the interface range fa0/1 to 2 and put them into the trunk mode by using the command switch port mode trunk. Now we'll go to switch 3 and put fa01 as a trunk port. fa01, I'm sorry, not fa03. The command switch port mode trunk. Now all of the ports which are being connected to another switch, so basically fa02 of switch 1 and fa01 and 2 of switch 2 and fa01 of switch 3, now all of these ports are trunk ports. Even if now you try making the communication between PC0 and PC1, it will go failed because trunk works on the basis of we can say a table which is created on the switch. So basically if we have a look at switch 1 VLAN table, so it will look like so we'll run the command show interface trunk and we can see the list of allowed VLANs. So this switch allows the data from VLAN number 1 and VLAN number 10. Similarly, if you will go to the VLAN table of switch 3, you will find the same information because on both of them VLAN 10 was created. But if we have a look on switch 2's VLAN table, by running the command show interface trunk, there's only one VLAN which is the default VLAN. So VLAN switch number 2 is not aware about VLAN 10. So if we try creating the VLAN here as well, let's say VLAN 10 and name it CCNA. So let's see if now the communication goes or gets failed. So so it says in progress. Okay. Mm, please. Okay, it's working now. So now when switch 2 is aware about VLAN number 10, if you try pinging from PC0 to PC1, it goes successful. So which means that every switch which is connected out there in the topology to another switch has to be updated with the VLANs which are there on the, let's say, switches which are getting connected to any end devices, right? But if we talk about a big network, or let's say with multiple switches, uh, let's assume that there are around 20-30 switches in between the end devices. So going to every switch in order to update details won't be a good idea, right? So in order to avoid that, we use VTP. So what we are going to do here now is we will be creating this switch as a VTP domain. So we will create this switch as a VTP domain. And once you create it as a VTP domain, it will start acting like VTP server, and these two switches, which are afterwards connected to switch number 1, will act like VTP client. Now we will understand what they do after becoming a client or a server. So once you configure VTP on any switch, that becomes VTP domain, and after that, whatever VLAN information you will configure on switch number 1, let's say you configure some VLANs, VLAN 10 and VLAN 20, then VLAN 30, then all of these details which are there in the database of VTP server, which is switch number 1, will be advertised to switch number 2 and switch number 3, and they will copy the same details in their database. Make sense? They will like copy VLAN 10, VLAN 20, 30 in their own databases. So it uses, in order to like advertise these, it uses VTP advertisements. So basically, these details are carried by VTP advertisements, and all of the switches which are there in the topology will copy the details in their databases. Do you guys understand how this works? Let me know if you have any doubt. Perfect. So I hope everyone is good with this. And now we will understand how the configuration looks for VTP. Okay, sure. So the need to use VTP is, imagine a topology like this. So let's say you have a switch here, then some end devices are connected to that switch. Now you have these two devices in VLAN 10. Okay, you have these in VLAN 10, then two devices here in VLAN 20. Now this switch is connected to another switch, and this switch then afterwards is connected to two switches. Let's assume this. Okay. Then on these switches, there are some end devices connected, which are part of again VLAN 10 and VLAN 20. Make sense? Now, in order to make these PCs, which are part of VLAN 10, communicate with this PC, which is again a part of VLAN 10, we have to configure all the VLANs on this switch and this switch as well, or let's say this switch as well. So, in order to avoid going to every single switch in between the network and configuring or creating all the VLANs on each single device, we create VTP server, and after creating VTP server, whatever configuration you will make on this switch related to VLANs will be copied by these switches automatically. So you don't have to like go to every single CLI of these devices and configure VLANs again and again. Make sense? And in order to make these communication, VTP advertisements are used, which carry the details about VLANs. Okay, awesome. So yes, Hassan, there is some, I guess, confusion. It sends out, so basically it's advertising the details which it carries. So VTP server is advertising the details to VTP clients, and then VTP clients add the same details in their own databases. So the only function of VTP server is advertising, not making copy of details on these devices. That's something which they do by their own. So let's now understand this on the topology and see how the VTP works. Let me just remove this. We have three switches with us, then a couple of end devices here and here. Take them. Okay. Now I'm going to configure a network of 10.0 on these devices. So 192.168.10.1. Similarly on PC2 it will be 192.168.10.2. Then we will go to PC4 and configure the IP of 192.168.10.3. Okay. Go to CLI of switch 1. Create VLAN 10, name it as, and take an exit. Put interface range FA0/122 and switch put access VLAN 10. Then create create interface FA03 as the trunk port. Interface FA03, switch port node trunk. Now go to switch 4 and put FA01 and FA02 as trunk port. it. Go to switch 5, CLI. Now there's one more thing to keep in mind. The moment you create any switch as VTP server, it will delete the pre-existing VLAN configuration. So make sure you are configuring VLANs after creating VTP or after configuring VTP. So you create a switch as VTP domain using the command VTP domain, and after that you can put a name. So let's say CCNA. So it says that changing VTP domain name from null to CCNA. Now we can have a look at the details using the command show VTP status. And when you run this command, you will see that VTP domain name is now changed to CCNA. Then if we go to switch number 2 and say show VTP status, here also you will find that VTP domain name is updated to CCNA. Then similarly on switch number 3 as well, is updated. Okay, in case you don't find the changes on the device, you can again run the same command on that device as well. So we'll go like VTP domain. Okay. Okay. But what we can try doing is, let's try creating switch 3 as the VTP domain. So we'll say VTP domain, and let's change the name from CCNA to Cisco and see if other devices get updated with that. So in switch number 1, let's run the command show VTP status. Okay. There seems to be some issue, and let me check this. We can also see that if in the same topology you try creating two VTP domains, that will show you some error logs. So let me just check this out. Okay, so exactly, I know that, and I'm just trying to figure out that why is Swiss 3 not accepting CCNA as the VTP domain. Let me just do the same. Okay. Okay, perfect. So now all the three switches are a part of VTP domain CCNA, and now we'll see the moment we create. Okay, so now we don't have any VLAN configuration on these devices, right? Even if we have a look at show VLAN brief, we can see that, okay, so there is VLAN 10 created on this device, of which FA01 and FA02 are part. And if we go to switch 4 and see show VLAN brief, there is no such information as of now. Show VLAN brief. Here as well, we don't have any information. Just remove it from here as well. And now we have only one VLAN, which is VLAN number 1, which is the default VLAN, and we don't have any other VLAN on this switch as of now. So we'll go to configuration mode, and the moment you create another VLAN, let's take VLAN 20 and name it as Cisco, then we can observe that on other switches as well, the same will be created. So we can see on switch number 2, there is another VLAN added into the list, which is VLAN 20 with the name of Cisco. This means VTP is working successfully, right? Now, if we go to VLAN switch number 3 and run the command show VLAN brief, here also we can observe that VLAN 20 is there in the table with the name of Cisco. Make sense? Now you can make these two interfaces a part of VLAN 20, and after that your communication between devices will go successful. The command interface range fa0/2 to 3 and make them a part of VLAN 20. Switch port access VLAN 20. And on this devices as well, this range fa0/1 and 2, then switch port access VLAN 20. Now if we try making communication between devices, it will go successful. You see, it goes successful. So the moment we create this switch as a VTP domain, it will start advertising the VLAN information it have in its database to other devices. So even after not configuring VLAN on switch 4 and switch 5, the communication is getting successful. So do you understand how VTP works? You just have to make sure that all the devices are part of same VTP domain, and after that you can put the configurations and it will be advertised to all other switches. Yes, you can put them into the VTP client mode, and that will be more beneficial so that no changes can be done using these devices. And we'll say VTP mode client. So now this device is a client device and it cannot create any changes on the whole topology. And similarly, we'll go to the switch 3, take an exit, mode, client. Let me know if you still have any questions or doubt with this practical. Otherwise, take your time and try this out and let me know once you are done with this. Okay. So the steps will go okay, step 1, to create VTP domain, and the command will be VTP domain CCNA. Then after that, create VLAN 10, name Cisco, take an exit and select the interface range A0/122 and run the command switch port mode, switch port access VLAN 10 will be done on switch number 1, then on switch number 5 you will go this range FA0/2 and 3, then run the command switch port access VLAN 10. Also make sure you make them VTP client by running the command VTP mode client like this on both of the devices. Yes, exactly. You are correct. After you put them in the client mode, they cannot create any changes on the whole topology. So basically, they'll be only be able to like copy the database, which is or the VLAN information provided by the VLAN server, which is switch number 3. So this is the VTP server. Okay, try this out and let me know once you guys are done with this. Okay, so and if we talk about the transparent mode, so basically transparent switch won't participate in such VTPs, and any changes you make on transparent mode will be like configured locally on that device only. So I was on mute. So basically, transparent mode is something like you'll be able to create, modify, or let's say delete VLANs locally only, but not on the topology. So like transparent mode, something between uh, server and client, but so we can understand this by keeping it in mind that it doesn't participate in the VTP domain if you put any switch to the transparent mode. Okay, yes, you also have to create these ports as trunk ports. So I would request you to have a look here. So this is something I have found to understand the different modes more accurately. So the first of all, we have a first mode as VTP server, which we create on which we create the VLANs, and after that those VLANs are advertised to other switches, right? Then we have another mode which is VTP client. On VTP client mode, you just copy the information received into your database, so you cannot make any changes on your VLANs. Then there is another mode which is VTP transparent mode. Now this does not participate in VTP domain. However, but if like two devices are connected with a transparent mode switch, it will pass the information to that next device. And also like it can create, edit or delete VLANs locally. So basically whatever changes will be made on a device which is in VTP transparent mode, it will like it will make changes locally only to devices which are directly connected to that switch. I hope now this is more clear to you guys. So I'm removing this and you can continue your practical. Okay, so I hope you guys are done with the practical and we are good to move ahead. Now, okay, just a minute. Now I'm going to introduce you to something which is very, I would say, is very much in demand and is known as automation and programmability. Now, when we talk about automation or making networking automated, there comes something known as SDN, which is software defined networks. And you all must have heard about this as of now. If you are trying to be a network engineer, if you are trying to be a part of this field, you all must be aware about something called as automation or software defined networks, right? We are going to talk about that only, and we'll have a quick introduction about how automated network works and what all devices are used in making such networks or configuring networks or using automation and programmability. So when we talk about software defined network, we can like understand this by multiple meanings. You can understand this by configuring network devices using a software or maybe a controller or maybe using any other way. So basically, SDN were used in order to create packet forwarding techniques, um, I would say better, or you can understand that by saying that SDN was basically introduced with the perspective of creating a better packet forwarding technique. And but if we say as of now, as per our knowledge, which is we carry as of now, we know that packet when we talk about packet forwarding, it can be done using routing protocols, be it OSPF or EIGRP or say RIP and static routing as well. Now these techniques, or I would say protocols, work according to some planes which are available on all devices which are out there in the market. So there are some different planes. These work according to different planes uh, which are which are there on devices available out there. So it's not about only routers or only switches. These planes can be found, can be like observed on each and every single device which you see out there in the field of networking. So we have three different planes, and I would say every device has these planes. So the first plane is management plane. Then we have control plane. Uh, then we have data plane. Now, if we say, or if we talk about configuring a router, which is like connected with a management PC, it can be done either by using telnet or by SSH, right? Now you can understand this by saying that it provides the uh, capability to restrict the interfaces, or in such cases when you are trying to configure a router using a management PC, here we are getting connected, or we can say we are playing with the management plane of this router. Make sense? So here you are using, or we can say you are like uh, provisioning into the management plane. Now, after getting connected to this router using either by telnet or SSH, you will like obviously make some configurations, right? So um, now control plane comes into the picture. So once these are connected using the management plane and you create some configurations, control plane comes into the picture, and control plane can be considered as um, it is a plane on network which is okay. So we can say that control plane on network is intelligent logic of the device. Uh, like all the protocols which you configure, like OSPF, EIGRP, and RIP. In that case, you will be provisioning control plane while that configuration. Now, so I hope you guys are able to understand. While getting connected, you are provisioning management plane. Then after that, when you try making some configurations, you make some changes to the intelligent logic of the device. At that time, you are provisioning control plane. Now, with this, a device maintains routing. Okay. With this, these devices maintain some uh, routing information base, or we can say the forwarding information base on the control plane, which is nothing but you can understand by the routing tables. So all the information about routes can be stored in these information bases, and these are stored in the control plane. Then after that, control plane gives the information to the third plane, which is the data plane, and about all the routes, and data planes takes care of forwarding the traffic. You understand what are the all functions of these three planes? So basically control plane tells the data plane about all the information which is there for forwarding the traffic, and data plane takes care of that. So every single device out there, be it a router, be it a switch or a PC, will have these three planes, which are management plane, control plane, then data plane. Management plane, control plane, then data plane. Similarly like this. Now, if we say, if we consider a topology like this, where we have a router number one, then another router number two, and then they have switch connected to them like this. And after that, on this switch, there are some end devices connected. So let's say this is switch one, this is switch two, and this router number one is connected to switch one, and on switch two, this is how a traditional network look like. So router number two will be connected to switch one as well as on switch two, and there will be a management PC which can be used to make some configurations on these devices, and this management PC will be connected to router number one, then with router number two, then with switch number one, then with switch number two, and let's say if you try assuming another router with another switch, then you can imagine some connections like these as well. So router 2 will be connected to all three switches, then router 1 will be connected to all three switches, and similarly router 3 with switch 2 and switch 1, then this management PC will again be connected to these devices. Now, at first, when SGN were introduced, or SGN was introduced, it was the sole purpose or the perspective was to make data forwarding better. But when we observed the requirement of network, then, or you can say the need of production, it was, I would say that, uh, so basically management can be considered as the need of production, right? When it comes to data forwarding, in that case, protocols like RIP, OSPF, and EIGRP are working well as per their own capabilities. So SDN came into the picture and it decoupled control plane and data plane on these devices. So there will be like management, control, and data plane on router 1, then on router 2, similarly on router 3, then on switch 1, then on switch 2, and on all other devices which are there in the network. Now what SDN helps you to do is it it gives the control plane to management PC. So now these devices which are there, router 1, router 2, router 3 and switch which are connected to them are now left with the management and data plane only. So once these are connected with the uh, management PC, which is this, once these are connected using telnet or SSH, for which you will be provisioning management plane. After that, you can make changes on this particular management PC, and that changes will occur in the control planes of all these devices which are connected. Make sense? Do you understand how this works after this SDN came into the picture? So basically, excuse me. So basically, configurations will be done on management PC, since it has the control plane of all the devices. I hope everyone is clear till now and we are good to move ahead. Okay. So first part, I'm sorry, Abhijit, I didn't saw your message and didn't see your message before. Yeah. The very first part was about management and control management and data plane only, about their functions. Now we'll move forward. So now there is some drawbacks as well when it comes to automation or programmability. There are multiple platforms which are there, like iOS. Then we have uh, ASAOS, then NXOS. There are multiple platforms on which devices are like configured. iOS XR and iOS XE. Then we have SD-WAN, ACI. Now, as of now, we have only observed, or we can say we have only worked with devices with iOS, right? And iOS supports Telnet and SSH. And if we talk about these, the rest of the platforms which are there, we can say that they have the ability to configure network or configure devices using some protocols like netconf, and RESTconf, or you can say REST API. We'll talk about them now. And these are like the available programmability options, or you can say these can be called as API, which stands for Application Programmability Interface. And we will understand how they work. So basically, the role of a API is making our configurations, our like human understandable configurations. Um, so the role of API can be considered as converting the human understandable configurations to PC understandable configuration. I hope I make sense to you guys. So I hope you guys are able to understand what I'm trying to say. So whatever commands you use in order to make configurations, PC don't understand them. When it comes to these platforms, we'll talk about them separately uh, after a few minutes. But as of now, you can understand the role of API is converting that human understandable commands into something which can be understood by the PCs or routers or devices. Make sense? Do you understand the role of API? Okay, so if we talk about configuring devices with iOS, we can we know that Telnet and SSH can be used with a management PC. If you connect a device which works with iOS, you can configure that device using Telnet or SSH, which we have already done into the in our practicals in Packet Tracer, right? But when it comes to these platforms which are there available, uh, these can be configured using some protocols, namely netconf, restconf, and REST APIs. And APIs stand for Application Programmability Interface or Programming Interface. And the purpose of these protocols, or you can say these APIs, the purpose of these are to convert the human understandable configuration, the changes you make on the devices getting converted into something which can be understood by the PC. Then after that, we will be understanding this more accurately once we have a look at the example. So, or let's say you have a router here or a management PC here, then you have a router here getting connected to it. So you use Telnet and SSH, right? And in order to configure that, in order to make that connection, you run some CLI commands. But when it comes to other platforms other than iOS, we use something known as GUI, which stands for graphical user interface. Now, the changes you make on this GUI is something which we understand, which humans understand. And those changes, let's say these are the some changes which you make on the device. Now, these changes will be converted into something which can be understood by PC. And this conversion, so basically, this conversion is done by API. I hope now it's clear the role of API, right? Okay, perfect. So let's suppose that you get a firewall and now you can configure that either by using CLI commands, which is the way we have been doing since now, or by using the UI or GUI Like there are some applications which can be used under this, like ASGM. Now ASGM stands for Application Security Data Manager. Now you install this ASGM on the, I would say, management PC. You install it here, then you open it and you make the configurations on this PC using GUI, which is graphical user interface, which we human understand. Then after that, so whatsoever device it will be connected to will understand that only if that configurations are converted using the API to something which a router or a PC or a switch can understand. So basically API convert our configuration into device understandable configurations. If we talk about this, we know how now things work using a API or GUIs, but still there is something where we are lacking. Even if we try using this method, we can only configure one device at a time, right? Like let's say the example we took, which was a firewall. So let's say you connect that firewall with the management PC and you make the changes on the GUI. Then after that, those configs are later on converted to something which can be understood by the firewall using a API, and the configuration goes successful. But the issue is still you are just like the traditional method, you are still configuring one device at a time. Now there was a need to discover something which can be used to configure multiple devices at the same point of time. So in order to improve, I would say around 2001, a workshop was held by IETF, and in that workshop, people from organizations like Cisco, Juniper, or I would say some other network vendors like Huawei were invited to find out a protocol which can be used to configure multiple devices at the same point of time. Uh, and they come up with some solutions like netconf, yang, and restcon. Now, if we say netconf, it was I would say launched in 2006. Then Yang was there in 2010. Then RESTConf was there in 2017. Now we can use these using Python. The language Python can be used in order to uh, make changes on multiple devices at the same point of time using these protocols. You understand how this works? Let me know if you have any doubt till now or if you find something difficult to understand. Okay, great. So now with this, there comes something called as on-box programmability and off-box programmability. So if we talk about on-box programmability, it is done directly on the devices. So as we took the example of firewall configuration, where we were directly getting connected with the firewall using a management PC, that was